This is a lesson on combining transformations. So we will be looking at transformed graphs that have more than one transformation. So they'll have stretches, reflections, translations all together, and we have to come up with an organized way of looking at them. So to begin with, if we take a regular function y equal f of x, so any function y equal f of x, and we look at the fully expanded or transformed version of it, we would get y is equal to a times f at b x minus h plus k. So this is a little complicated, but it's got every transformation indicated on this, and let's take a closer look at it. So first, when we've got the y isolated, such as we do now, which is the most common way of having it, the factor of a in front gives us a vertical stretch by a about the x-axis. Then the b, which is, notice it's in a bracket, but you'll see more of those later. This indicates a horizontal stretch by a factor of 1 over b about the y-axis. So again, notice that the b, the horizontal transformation, is always the reciprocal of that factor. And then we've got a horizontal translation of h units. Sign is opposite to direction. And then a vertical translation of k units. Now, I did not include in this one the reflections, but those would be found with the signs of a and b, and we will see several of those shortly. So, let's take a look at 3 or 4 questions. And we will have to describe them in terms of their transformations. It's not stated here, but what we're really doing is comparing them to their untransformed form. So if we take a look at this absolute value function, f at x minus 2 is equal to 1/3 times 2x. Now, before we identify what's going on, we should isolate the y variable. So I'm going to add 2 on to both sides. So we get this. F at x is equal to 1/3 2x plus 2. Now that step was not necessary. Some people get good at these transformations and they don't do that. But normally you isolate the y, particularly if you want to use your calculator, which requires you to do so. And here we have 1, 2, 3 transformations. We first off have a vertical stretch by a factor of 1/3 about the x-axis. And we have the next, a horizontal stretch by a factor of 1/2 about the y-axis. So keep in mind, as we saw, the b value, the x coefficient, will always give you be the reciprocal of the stretch factor. And then finally, we get a vertical translation of 2 units upward. Take a look at the second one. Y over 4 plus 1 is equal to 3 to the exponent of negative x. Now first, this is an exponential function. The x variable is in the exponent. The base is 3, but that is not a transformation. It just tells you the steepness, the relative steepness of that exponential graph. Now I need to manipulate this one. Got to get that 1 over on the other side, or I should do so at least. So y over 4 is equal to 3 to the negative x minus 1. And now, a very important step. I need to get that, clear that denominator, the 4. So I will multiply all terms by 4. And that will give me y is equal to 4 times 3 to the negative x minus 4. You cannot multiply the 4 by the 3 because the 3 has an exponent, which takes priority over multiplication. and of course the 1 gets multiplied by the 4. But now we're set up, and we should be able to identify the 1, 2, 3 transformations. So first, we have a vertical stretch by a factor of 4 about the x-axis. So when you have the y isolated, the vertical transformations are honest. If there's a 4 in front of the function, it means it's a vertical stretch by a factor of 4. Then, we have a reflection in the y-axis. Because x has been replaced with negative x, it means it has been reflected in the y. And then the last transformation would be the vertical translation. And that would be 4 units down. Let's take a look at another one. Now this one brings up a very important step. We're given a square root function 2x plus 6. And if you didn't look at this one carefully, you'd say, well, I have a horizontal translation of 6 units left. But you'd be mistaken, because we have to factor out that 2 before we can identify the horizontal translation. So if you go back to the very first thing we looked at, you saw that the b value was in a bracket outside the x plus 6. And this is very important. You must factor out that 2 or any coefficient with the x. So this one, we factor out the 2 and we get x plus 3. So that both the 2x and the 6 get divided by 2. And now, and only now, can we recognize the horizontal translation. It's not 6. It's actually 3. But in the meantime, I note that there is a horizontal stretch by a factor of 1/2 about the y-axis. So again, it's the reciprocal of that factor with 2, or factor with x. And then we see we have a horizontal translation of 3 units left. So again, we note that when we have it in this form, the horizontal transformations are always opposite. That is, if there's a factor of 2, it's actually a stretch factor by the reciprocal. And whatever the sign is on the translation is always opposite. So the x transformations are always dishonest. They're always lying to you. Let's take a look at number 4. Now, this is a messy looking one. It is actually a reciprocal function of form y is equal to 1 over x. However, lots has happened with this one. Now again, we need to get that x isolated. So we have to factor out that negative 1/2. So that means both terms on the denominator, the 1/2 x and the 3, need to be divided by negative 1/2. So we do factor out negative 1/2 from the x term. This is a risky step. People make mistakes with it all the time. But when you divide by negative 1/2, of course, the x term is now isolated, which we want. But 3 divided by negative 1/2 is 3 times 2, which is negative 6. And if you distributed the negative 1/2 in, you'd see that we did this one properly. And now we're set up. There is a factor, a vertical stretch factor of 3 about the x-axis, because it's supposed to be a 1 over x, and this one had been multiplied by 3. Then there's a reflection in the y-axis. That would be the negative that was with the x, because really what had happened was the x had been replaced with negative x, or negative 1/2 x, if you prefer. Then we have a horizontal stretch by a factor of 2 about the y-axis. Again, the reciprocal of the factor or coefficient with x. And now there's one more. And that would be the horizontal translation 6 units right. So this is a heavily transformed graph. Lots going on with it. So this is the basic information. The next lesson will include some applications and some things that you will see related to all this. So thank you for your time.